Today we are going to learn how to solve systems of equations using matrices. And this will be our last section on solving systems for right now. Hopefully you will like the methods that we come up with here. For a quick review, an m by n matrix is a rectangular array where we have m rows and n columns. M and n are required to be positive numbers, and each entry in our matrix is also a number. If our entire matrix is just one row, we call it a row matrix. If our matrix consists of just one column, we call that a column matrix. And here we've got an example of a square matrix or a 2 by 2 matrix. So let's take a look at writing what we call an augmented matrix. And this is going to be the first step in using our matrix in order to solve this system of equations that we're given here. The first thing that you want to do is you want to line up your variables so all of your x's are in one column, all of your y's are in one column, all of your z's, w's, and then you've got all of your constant terms on the right-hand side of the equation. So let's take a look at what our matrix is going to look at. And I'm just going to pull the coefficients off of all of our variables. So for the first row, we've got 1x, 3y. And just like when we were doing synthetic division, we have to put in placeholders. So there are 0 z's minus 1w. And now I put this dotted line here to indicate that I'm done with coefficients of variables, and what's on the right hand side is the constant. Second row, we've got 0 x's minus 1y, 4z, 2, and negative 2. Third row is 1, 0, negative 5, negative 6, and my constant is 0. And your last row is 2, 4, negative 3, 0, 4. So this is our augmented matrix for this system of equations. Once we have our matrix written, we can do just like you did with your systems of equations in section 7.3. Just like there, you could interchange two equations. Well, we can interchange rows in our matrix. We can multiply a row by a non-zero constant. And we can add a multiple of a row to another row. And the whole point there is that we want to get our augmented matrix into row echelon form, just like we did in the last section. So what does that look like as far as your matrix goes? Well, you've got a diagonal here of 1s, and everything below and to the left of that diagonal is 0. Now there's also another form of row echelon, and that is reduced row echelon, where in addition to the zeros below, you also have zeros above. But we're going to mainly be interested here in looking at row echelon form. Let's go ahead and do an example. I have already written the system of equations so that our variables are lined up and our constants are lined up. So let's go ahead and write our augmented matrix. For the first row, we've got 0 in front of the x. We have 1y, 1z, minus 2w, and our constant term is minus 3. For the second row, we've got 1, 2, negative 1, 0, and our constant is 2. Third row, 2, 4, 1, negative 3, negative 2, and your last row is 1, negative 4, -7, -1, and -19. So that is our complete augmented matrix. And what I want to do now is I want to perform some row operations so that I can get that diagonal of ones. As you can see, we already have a little bit of a problem because right here our first entry is a 0, but we need that to be a 1. So what we're going to do is we're going to take our 1 and we are going to swap it with our 2. So our new matrix now looks like 1, 2, -1, 0, 2, and we replace row 2 with row 1. And the last 2 rows just stay the same. This should be somewhat of a review from Algebra 2. Okay, next step, if we look down, second row we're okay. We've got a 0 here and a 1 here. But if we go down to our third row, we've got this 2 and this 4 that we're going to have to take care of. So what I want to do is I'm going to multiply row 1 by -2, and I'm going to add that to row 3. So we'll move up here where we've got a little more room, and we get, for -2, R1 plus R3. We have -2, -4, 2, 0, -4, and then we have row 3 is 2, 4, 1, -3, -2. Add these together, 0, 0. 2 plus 1, we get 3, -3, and -6. So that is our new row 3. So what does your matrix look like now? First 2 rows are going to be the same. And then we get to replace that third row with the one that we just modified. And your last row is still the same. Oops, that should be a 1. -4, -7, -1, -19. Next operation we're going to do, we want to take care of this 1 out in front here. So let's do -1 times row 1, because that's the only one left that has any numbers in that first spot. Okay, so we're going to do -R1 plus R4. And what we end up with is first row stays the same. Second row is going to stay the same as well. Same for the third. And your last row now is going to be 0, -6, -6, -1, -21. This slide's getting a little bit crowded, so I'm going to have to switch to a clean slate here. But before I do that, let's identify what we're going to do for our next row operation. We're going to do 6, because we have to get rid of the 6 right here, and we've got a 1 here. So we're going to do 6 times R2, and we're going to add that to R4. Let's take a look at what that looks like. So 6 times row 2 gives us 0, 6, 6, negative 12, negative 18, and your last row was 0, negative 6, negative 6, negative 1, negative 21. Add those up and we get negative 13 and negative 39. Our new matrix now is going to be 1, 2, negative 1, 0, and 0, 1, 1, negative 2, negative 3, and our new fourth row is 0, 0, 0, negative 13, and negative 39. Now I just have 2 pieces left to take care of, and that is I've got a 3 here and a negative 13 here. So all at once I'm going to multiply row 3 by 1/3, and I'm going to multiply row 4 by negative 1/13. So now my final matrix in in row echelon form is now we have 1 and negative 1 and negative 2, and we have 0, 0, 0, 1, and 3. So we can see we've got our diagonal of 1s and our 0s. So now we are ready to do the back substitution. So what this last row here says is that we know W is going to equal 3, and this row says that Z minus W is equal to negative 2. The equation The equation that goes with row 2 is going to be Y plus Z minus 2W equals negative 3. And our top equation is X plus 2Y minus Z. And we have 0 W's, so this equals 2. So now let's plug 3 in for W and figure out what Z is. Z minus 3 is going to equal negative 2. So Z is going to equal 1. So now let's plug W and Z into this equation right here, and we get Y plus 1 minus 6 equals negative 3. So Y is going to equal negative 5. So we're going to have to add 5 to both sides. So 5 minus 3, Y should be 2. And now let's substitute Y and Z into our top equation, and we get X plus 4 minus 1 is going to equal 2, which means that X is going to equal negative 1. This means that our solution to the system is negative 1, 2, 1, 3. I don't know about you guys, but that was an awful lot of work to go through to get to our solution. So what I'd like to do now is show you an easy way for you to solve matrices using your calculator. So the first thing that we have to do is identify what we call the coefficient matrix, and it's just what it says. It's a matrix of only the coefficients on your variables. So we've got 0, 1, 1, -2, 1, 2, -1, 0, 2, 4, 1, -3, and then 1, -4, -7, and -1. And typically we're going to assign this to be matrix A when we put it in the calculator. And then the constant matrix is right here. It's the column -3, 2, -2, -19. And we're going to put this in our calculator as matrix B. So let me bring up the calculator. And sorry, I have to do some adjustments here. Okay, now that we've got the calculator view up, hopefully it's working and you guys can see it all right, I'm going to show you how to solve that system of equations using the two matrices that you hopefully wrote down. To start off with, hit second and the X inverse key. That's going to take you to the matrix menu. Then you're going to arrow over to edit, select number 1, matrix A, and hit enter. And that matrix is going to be a 4 by 4 matrix. And we're just going to start inputting our values. So we had 0, 1, 1, -2, 1, 2. And again, these are just the coefficients from our system of equations on the last slide. And just a couple more here. Okay, so we've got our coefficient matrix now, and it is matrix A. Now we want to do our constant matrix. So second and hit X inverse again. And then we're going to go over to edit. And this time we're going to edit matrix B. And this time we want a 4 by 1 matrix. Put your constant values in. So we had -3, 2, -2, -19. Okay, now you're going to quit from that menu. And you'll have your matrices saved. And this is the part I think you guys are really going to like. We go to matrix, hit enter, selecting matrix A, and we want A inverse. And we're going to multiply that by matrix B. Now you guys have seen the inverse matrix before. You should have done that in Algebra 2. And so we're just going to multiply A inverse times B. And there should have been your solution to that system, but I must have entered something wrong. Okay, so I went back and I checked my matrices and I had made an error entering in my data. So be sure if you're not getting the solution that we got before that you go back and check your data. But as you can see now, I got for A inverse B my solution of -1, 2, 1, 3. And that matches our solution from earlier in the podcast. So that is a nice quick way to solve a system of equations using your calculator. Here are some problems for you in order to review for your quiz next class. So be sure to write these down and do these problems for next time. Okay, great job everybody, and see you in class.